Assalamualaikum warahmatullahi wabarakatuh. Uh, Today, I will be presenting about Lab1 Exercise 1, adding and subtracting 32-bit integers. In this lab exercise, we'll be looking at a code that adds and subtracts 32-bit integers using assembly language. We will go through the code line by line, explain what each line does and how it works to achieve the final result. Code starts with a title, followed by the inclusion of the Irwin32 library, which contains pre-written functions for assembly language programming. Next, we have .data section, where we declare a single variable named total as dword. Dword stands for double word, and it is a 32-bit integer type. This variable will be used to store the final result of our arithmetic operations. After the data section, we have the code section where the main program resides. The main procedure is where the execution of the program starts. We start by moving EAX register to the value of 123400 h using the move EAX, 123400 h instruction. EAX is a general-purpose register that is used for many purposes in assembly language programming. In this case, we will use it to store the first operand for our addition operation. Next, we add the value of EAX with 567800H using the add EAX, 567800H instruction. This instruction adds the value of 567800H to the current value of EAX and stores the result back in the EAX. We then subtract the value of EAX with 77700H using the sub EAX 77700H instruction. This instruction subtracts the value of 77700H from the current value of EAX and stores the result back in the EAX. Finally, we store the value of EAX into the total variable using the move total, EAX instruction. This instruction copies the value of EAX into the total variable, which is then displayed using the call dumpRex instruction. In conclusion, we have looked at a code that adds and subtracts 32-bit integers using assembly language. We went through the code line by line, explaining what each line does and how it works to achieve the final result. By the end of the program, we were able to store the result of our arithmetic operations in a variable named total, which we display using the call dumpRex instruction. Assembly language is a low-level programming language that requires a good understanding of computer architecture and is still used today in many critical applications, such as embedded systems, device drivers, and operating systems. So that's all for Lab1 Exercise 1. Thank you.
Assalamualaikum. Today I will explain about the exercise 2. So first, let's talk about the purpose of the code. This program is designed to add and subtract 32-bit integers and then store the resulting sum in a variable. So the program begins by including the Irwin32 library, which contains useful function for working with input or output and other system functions. So the data section of the program is where we declare variables. In this case, we have 4 variables, which is first we have val1, val2, val3, and final val. Each of these variables is a dword, which stands for double word. Dword represents a 32-bit integer. We assign initial values to val1, val2, and val3, but leave final val uninitialized. Moving on to the code section of the program, we begin with the main procedure. The first instruction of the main procedure is to move the value of val1 into the EAX register. This instruction is accomplished using the move command. And then next we will add the value of val2 to the EAX register using the add command. This instruction adds the two values together and stores the result in the EAX register. Then we will subtract the value of val3 from the EAX register using the sub command. This instruction subtracts the value of val3 from the current value of the EAX register. And finally, we will move the value of the EAX register into the final val variable using the move command. This instruction stores the resulting sum of the previous operations into the final val variable. Once the final val variable has been assigned a value, the program calls the exit function, which ends the program. Now, let's talk about the output of the program. Since this program does not have any output statements, we need to use a debugger to see what values are stored in the registers at the end of the program. The output of the program is displayed in the form of register values: the EAX, EBX, ECX, EDX, ESI, EDI, EBP, ESP, EIP, and EFL registers are displayed, along with their corresponding values. In this case, the output shows that the final value of the EAX register is 00613500 hexadecimal. This is the result of adding 10000 hexadecimal and 40000 hexadecimal, and then subtracting 20000 hexadecimal, which gives us 30000 hexadecimal, or 00613500 hexadecimal in hexadecimal notation. In conclusion, this program demonstrates how to perform basic arithmetic operations on 32-bit integers and store the result in a variable. By explaining the purpose, variables, and instructions of the program, along with the output, you can effectively present this code to your class in a 5-minute video. When you use step over in the code, the debugger will execute the current line of code and then move to the next line. In the case of the code above, if you use step over on each line, the debugger will do the following. Move to the next line of code after the main prop label, load the value of val1 10000 hexadecimal into the EAX register. Add the values of val2 40000 hexadecimal to EAX, which now contains 50000 hexadecimal. Subtract the value of val3 20000 hexadecimal from EAX, which now contains 30000 hexadecimal. Store the value in EAX into the final val variable. If you use step over on each line, you will be able to see each step of the calculation and how the value in the EAX register changes. So that's all for the exercise 2. Thank you.